Hello, today I am Suman Kumar Chaudhary. I will teach you the chapter current electricity which is related from class 10. As you know that electricity is very essential for our daily life, and we cannot imagine our daily activities without electricity. Many factories, trains and household appliances all run through the electricity. And you have been already studied about electricity in your previous classes. So here we will discuss the current electricity. First, we know that the electricity which is related from the charge, and this electricity is divided into two parts, which is the static electricity and second is current electricity. What is static electricity? Static electricity means the kinds of conductor in which the charge cannot flow, like all the kinds of non-conductor. Non-conductor, for examples, plastic, glass, rubber. These kinds of insulator which doesn't carry electricity, it means the electricity is remain in this conductor and this electricity cannot flow. Means the charge will develop on these conductors, on these kinds of the insulator, but the charge will not flow from one place to the other place. Suppose that when you will take a comb and when you comb rub with your dry hair, and if you put some pieces of paper, you will see that the pieces of paper attracted by the combs. It means the comb developed a charge, and due to the rubbing of our hair, but this pieces of paper doesn't get any charge, because we know that all the kinds of the matter are electrically neutral. Electrically neutral means the matter which doesn't carry any kinds of charge, either positive charge or the negative charge. And when the comb rubbed with our dry hair, it gets a charge. Here we will see some the facts which is related to chemistry. Then you can understand better. We know that all the matter, all the particles in the universe are made up of three kinds of the subatomic particles, and that particles are electron, proton and neutron. As you know that electron is the negatively charged particle, proton is the positively charged particle, and electron has no charge. So all the matters contain same kinds of the same amounts of the electron and same amounts of proton. It means if you take any matter, suppose that sodium its atomic number is 11. It means electrically sodium has a neutral because it has 11 proton and 11 neutron. 11 electron. And both, as we know that the electron is negative, proton is positive, so both negative and positive cancel to each other, and then this matter becomes neutral. So similarly, here we will discuss how the electron gets charged. First, we know that the construction of the any kinds of elements or matter. All the matters, as we have been studied previous, that matters contain three kinds of the subatomic particle: electron, proton and neutron. So proton and neutron present at their nucleus, while electron is revolving around the nucleus in a certain fixed path. This electron, and only electron is in motion. So if any objects or the particle when rub to each other, it loses their electron, and other particles which gain the electrons. So electron is only in motion, so electron lost their any particles loses their electrons and gain the electrons. So those kinds of the particles or the object which lost their electrons, so it gets a positive charge because it's lost the negative charge, and the other kinds of the object which gain this electron, so it's become a negative charge. So charge means it is a kind of force which applied by any object in electromagnetic field. Here we will see some about electromagnet. What is electromagnet? Electromagnet means when any object carry a charge. Suppose that this is any conductor. There, as you know, there are the two kinds of the object. One is conductor and other is insulator. Conductor means the substance which carry the electricity from one place to the other place. Conductor means the substance which carry electricity. And insulator, this doesn't carry electricity. So all the kinds of the conductor which carry electricity, it developed a magnetic field around it. Actually, it is the property of the electricity. You have been already studied about magnetic effect of current in your in previous class, in class 8. Magnetic effect of current means the any substance which carry the electricity in conductor, it's developed a magnetic field around it, and this magnetic field applied a kinds of force all around. Suppose that we'll take a cell, and this cell is connected to a copper wire, insulated copper wire. Suppose that this is a cell. And this cell will connect with the help of insulated copper wire, and we'll put a simple magnetic compass between it, and as we switch on, we'll see there is a deflection in the magnetic compass. What does it mean? It means that the electricity has a kinds of property, and this property is the magnetic property, and the fan is moving. Why the fan is moving? Because when the electricity flow, it develop a magnetic field around it, and due to this magnetic field, it applied a force all around the head of the fan, and then this fan is revolve or rotate about its axis. So here we'll discuss about the charge. Charge means it is the kind of force which applied on a magnetic field when electricity flows. So we are discussing about the kinds of the electricity. As told, two kinds of electricity, static and other is current. Static, you understand? Static means where the charge doesn't flow.
नॉटिट्यू मिटा देना है
Static electricity. Static electricity, you understand? Here, static electricity means the charge doesn't flow, and in current electricity means where the charge flow. As I told, three kinds of the subatomic particles. So in modern physics, two kinds of charge. It is a positive charge. Positive charge means it is proton. And second is negative charge. Negative charge means it is electron. And both have the same kinds of value. Proton means it has charge plus 1.6 into 10 raised to the power minus 19 coulomb. Why is it written here plus? Because plus sign shows the characteristics of this charge. And the same in the negative charge, it is minus 1.6 into 10 raised to minus 19 coulomb. Coulomb is the unit of charge. It is the given honor of the name of the honor of the scientist Charles Augustine Coulomb. And when the electricity doesn't flow any metals or any conductors, so this plus and this minus, because the numerical value of both the electron and protons are equal, so it is cancelled to each other. Now we will discuss about the another things. So are you understand what is this? In modern physics, two kinds of charge. This is positive and negative charge. Positive charge we can say it proton, and a negative charge we can say it's electron. Both have the same value. It is 1.6 into 10 raised to minus 19. It is plus and it is minus. Minus means its minus sign shows the negative charge. Now, when the charge flow from any conductor, it's develop a magnetic field around it, as I told. This magnetic field exert a force, and this force, first observed by the scientist, it is a Coulomb. He told that if you take two charges, Q be the charge. Actually, about this topic you will study detail in the class 12, but here we will discuss about the charge. So this theory is, this concept is very important. Here we will take two charge. It doesn't matter the charge are positive or negative. So here we'll take two positive charge. And both the charge are separated by with the distance r. R is the distance between 2-point charge. Now, this charge exert of kinds of force between each other. This is, as you know that about magnet. Here we will give us an example about magnet. You know about magnet? Magnet has two kinds of pole. It's north pole and the south pole. When we will bring same kinds of pole, what happens? North and north pole and south to south pole. So according to the property of the magnet, there is repulsion between the same kinds of pole, and if you take one north and one south, so there will be an attraction between these different kinds of the pole of the magnet. So here we have been taken here two kinds of charge. So it means both the charge will repel to each other like a magnet. Charge behaves like a magnet, as I told. When the charge flow in any conductors, it develops a magnetic field around it, and this magnetic field exert a force all around. And if you put some magnetic substance like a magnetic compass, so we'll see there is a deflection on the magnetic compass, and this deflection due to the property of the charge which is flowing through a conductor. Now he said about this charge, and actually this concept you have been already studied in class 9, gravitational, universal gravitational force. What is universal gravitational force? In universal gravitational force, Newton's told about it that if you take any substance on the earth, suppose I will take two substances whose masses are same masses, m1 and m2, this difference, and the distance between r. What happens? Both these objects exert a force on each other, and this force is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. It means as we separate, both the objects separate by distance, then the force of attraction or force of repulsion. So here the force of attraction, because both the objects are on the ground and on the earth is also kind of magnet. So these two objects exert a force on each other, and it is attractive force. So as we keep this object apart from each other, or we can say as the distance between these two objects gradually increase, the force of attraction between two objects will decrease. It is inversely proportional. That is, yes, so it is inversely proportional. So same concept is applied in this law. So the charge exert a force on each other, and this force is directly, this suppose a Q1 and Q2 charge. So force is directly proportional to the product of the charges, and it is inversely proportional to the square of the distance between these two charges. This is equation 1 and 2. And when we combine this equation, it becomes F is directly proportional to Q1 and Q2, where F is the force which is exerted by these 2 point charge. And this F is also same force which is exerted due to the distance between these 2 point charge. It becomes Q1 and Q2 by R square. And when we will remove this proportionality sign, F equal to K Q1 Q2 by R square, and where K equal to K is a constant and its value is 1 by 4 pi epsilon 0, and its numerical value is 9 into 10 raised to the power 9 Newton meter square per coulomb square. This is the numerical value of K, means 1 by 4 pi epsilon 0. So we can write it F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is the required expression for this law. Now, here we will discuss about the property of the charge. What is the property of the charge? Property of charge. Property of charge. First property, as I told, charge behaves like a magnet. It is the same property of like a magnet. So first property is attraction. Attraction between two different kind of charge. Different kind means if one charge is positive and other charge is negative, then there will be a attraction between these two charges. Second is the repulsion. Repulsion between two same kind of charge. Same kind of charge means we will take two same kinds of charge. Either it can be positive or negative. So there are the two properties of the charge. So this is the topic which is related to charge. Now we will discuss about another topic, and this is electric potential. Electric potential means it is a kind of the property of the charge which flow from infinity to electric potential. Suppose that a charge which produces by an electric power plant, and this charge when reaches to a non-point, it is a non-point, and it reaches to the non-point. So whatever the work done by this unit charge from a known point to a known point is known as electric potential. What is electric potential? When a unit charge which carry from a known point to known point and whatever the work done by the unit charge in this segment, that is known as electric potential. Means electric and other topic which is related from this potential, and it is potential difference. Potential difference. What is potential difference? Electric potential and potential difference both are same, but there is very less difference between these two. When the electric potential, we have one known point and other is unknown point. But in potential difference, when the charge, it is unit charge, carry from two known point, it is also known point, and it is also known point. So whatever the work done by this unit charge, when it flow from one known point to the other known point, is known as potential difference. And potential difference we simply denoted by V. So we can write V equal to work done. Work done by charge, or V equal to work done denoted by W by Q. Q means a charge. And the SI unit of potential difference is volt, and we simply denoted by V. So SI unit of potential difference is volt, and volt is also it is given the name of the honor of the scientist is Alexander Volt. So SI unit of potential difference is volt, and the potential difference is when unit charge flow from one known point to other known point. Okay. Now we will discuss about the current elements. It means what is current? Current means, as it